Well, welcome. Today's our third series of the TigerGraph plus Plotly Dash, where Dan is going to explain to you, and make sure you stay till the end because we have an exciting announcement. So I'll hand it over to you, Dan. So thanks
Great.
again for coming.
Yeah, thank you, Kaylee. Thank you everyone for attending. Today I'm going to be covering a little bit of how you can use TigerGraph with Plotly Dash to visualize the results of your TigerGraph queries and to make a pretty cool web dashboard just using Plotly Dash and TigerGraph. So I guess kind of as a little bit of a teaser, I'm just going to show off the page that we'll be building. So we'll be using one of TigerGraph's starter kits, our movie recommendation starter kit for this. Actually, I'll go through the process of getting that set up if you would like to follow along with us, because this is an interactive demo, so more than welcome to follow along. So the first thing you'll want to do is just create a TigerGraph solution using our starter kit. Let me make this a little bit bigger for you. There we go. So you go to create solution, and then we'll be using one of our starter kits here. So we'll be using the movie recommendation starter kit. So that's this one, recommendation, movie recommendation. So you can just go ahead and click that. Next, and then you can create a free tier instance. You can leave all of these default. And then you'll just want to give it a name that you can remember. I'll just call this one Plotly Dash, and a password that you'll use to log in. By default, it's TigerGraph, all lowercase. So I'm just going to keep mine as that. And then you can give it a subdomain, which is what you'll use to actually access your graph solution. So we'll call this one Plotly Dash. And then you would go ahead, select next. And if all this looks good, you would click submit. Like I said, I already have a solution set up, so I'm not going to go ahead and hit submit. And we're just going to pop over to the solution that I already have. The first thing that you will need to do when your solution comes up, so it will take a minute or two to provision, kind of why I'm having you do this now, so we can go through some of the other stuff later. But once it does come up, it actually won't have any data loaded in it. The data will be mapped and ready to go. It's just not loaded. So what you'll want to do is just go from the cloud portal, click on these 4 boxes here where it says applications, click on Graph Studio, which will bring you to the Graph Studio page for your instance, and then click on load data. And then you'll just click this play button up here when that comes up. So we'll see with this one, there we go. And then you would just click this start resume loading and it'll load in all of your data. By default, you'll start off with 0, but by the end you should have something close to 40 million edges loaded into your graph. So what are we doing with this? What are we doing with these? I guess actually first, our graph is showing people rating movies. So this is pulled from, I believe it's IMDb. So these are actual movie ratings by actual people. Both the movies and the people, as we can see here, are stored by an ID string. So these are unfortunately strings of numbers. So we can't, obviously we don't get people's names or anything like that. But for our movies, we'll just need to interface with them as if they were a string of numbers. So let's see what we'll be building. This is our dashboard that we'll be building out. So it's a couple different pages here. I'll just sort of walk through each one quickly. And I'm just showing you this now so that way when I go and start actually describing the code, you can have a bit of an idea of what I'm talking about rather than just trying to imagine some dashboard until the end when I pull it up. So here we have the counts for each one of the different types of things that we have. So we have movies, we have 27,000 movies loaded in. We have 138,000 people loaded in. And then we have a little over 20 million reviews across 19 different genres of movies. So these are all just simple widgets that show us that type of information. And I'll walk through kind of the code to get all of this as we go on. We have an overview of the distribution of genres of movies. And then we have a list here of some 5-star films that we could scroll through. Additionally, we have a page describing specific movies. So here, for example, is one for Toy Story. So we can see a trend of average ratings over time. We can see a histogram showing that 4s are our most common ratings, and a box and whiskers plot of the distribution of those ratings. And additionally, we have a little iframe here, which just brings us to a Wikipedia page where we could see some more information about the Toy Story movie if we wanted to. And you could enter in any movie numbers up here. Like I said, these movies are described by number. It's a little bit hit and miss. Let's see if we can find one. We'll hit go. See that it is updating up here. And then here is our movie that we pulled out of it. This could at any point be updated to do something like autofill, where you start typing in the name of a movie and it actually queries the movie name. But just for this demo, we're keeping things simple and we're just going by these direct movie IDs. And then additionally, we have another page for person-specific stuff. So we have their total number of reviews, the average rating that they give to movies, and then this accuracy score is their rating compared to the average rating for a movie. So how close they typically rate a movie to what other people think of it. Additionally, we have a list of 1-star movies. This person has none, and a list of 5-star movies where we can scroll through here and see the movies that they've rated as 5 stars. And a pretty cool radar plot down here showing kind of the distribution of those genres across their ratings. And lastly, just a bar plot showing the number of films that they've rated within each genre. So that's kind of the overview of what we'll be building out. So let's hop into the actual code to see how we do this, because it is surprisingly simple using Plotly Dash. So this is, I'll send you this link right now, but this is where's the chat in a second? There we go. So this is the dashboard that we'll be following along with. This is actually a slightly modified version of dashboard built by one of my colleagues, Advit. So this will be a very quick abridged version of sort of the larger tutorial that he's built out. And I highly recommend that you check that out through whatever means interests you. He has a great blog post, a YouTube video walking through it, and a link to our TigerGraph cloud portal where you can learn some more about sort of these starter kits, the data in them, and what you're doing. So I highly recommend you check out his posts. This is sort of really a brief overview and kind of an introduction to it, and he gets a lot more in depth on a lot of these topics in those posts. So I highly recommend you check those out after this. So as with any project, the first thing that we'll need to do is install our dependencies and import them. So the main ones here that we'll be needing are TigerGraph. That's our Python TigerGraph interface. That's how we'll be actually interfacing with our TigerGraph solution. We'll need all of our Dash components. So this is just Plotly Dash. We're installing that. And pretty importantly, we're also going to need Jupyter Dash. So Plotly Dash does not natively run within a notebook environment. So you do need Jupyter Dash in order to enable Plotly Dash to work well with these different cells formats. So then we'll go ahead, just import what we need. And then first step is to establish our TigerGraph connection. So if you've been to any of these series in the past, you'll be pretty familiar with how exactly to do this. But this will be that subdomain, that domain that you created for your plot. So here we have plotly-.i, just tgcloud.io. And if we go to our actual solution, we can see that that is just our URL up here from the bar. You can also get that by going to the cloud portal, clicking on your solution, and right here in the domain is your domain name. And if you click on it, it'll actually copy it to your clipboard for you. So you can just easily paste it in here. Username and password, like I said, I left those as default. And our graph name is the default graph name of my graph. And we can see that just by going over here. You click on this icon and it will show you your graph name, as well as you can go and see the global view, which is kind of your global graph schema. So after connecting the first time, just to establish the connection to the TigerGraph server, we actually have to authenticate and create a secure connection with a token. So that way we can create and modify queries. And this block of code just does that. So it's commented out right now, but the first time you connect, you'll want to run it without this commented and with this commented out. So you'll want to generate a token, and then this will print off your token, and you'll take that printed token, you'll just paste it into auth token. And then in the future, when you want to connect, you can just use that auth token. This is just because there's this line here, create secret, where we're explicitly naming the secret that we want to create. And you can't create 2 secrets with the same name. So if you go to run this block of code again, without that commented out, it will error out and will not allow you to log in. So now that we're connected, we'll have to look at some of the queries that we're going to want to use for this graph, because we need to pull the data out of the graph. So we need queries to do that. And we have some cool things that we can do in order to get some of the neat metrics that we have here, like these distributions of the different the genres of movies, the box and whiskers plots, and kind of the, where did it go? The accuracy rating here. We can do some interesting things to get those metrics. So we're going to need to create queries for that. And each one of these blocks of codes just creates a different query. So this one is grabbing all the movies that a person is rated. That's pretty self-explanatory, and we can do that just by traversing out from that person vertex and traveling across the rate edge to any movies that they have rated. This next one gets the main genres of movies that they've rated. So it will, again, do that traversal, start with go out to all of the movies, and then form an accumulator, which is basically a list of all of the genres, as well as a count of each movie of that genre that the person has rated. This one is similar reviewers. It will find other people who have reviewed similar movies. Movie average rating is about that, exactly what it describes. Person accuracy score. So this is the one that actually computes their rating accuracy versus everyone else who has rated those movies. Movie quick info. This just gets some basic info about a movie. Movie date time ratings just gets that the data that we need to populate this bar chart here of their ratings over time. And all ratings, obviously, genre map pulls together that map of genres. Like I said, if you want more in-depth explanations on these actual queries, please check out Advit's blog post, which is linked both in this notebook, and I will link it as well at the end of this video. But he goes into a bit more depth about the queries. I just want to focus today on Plotly Dash and integrating with that. Afterwards, you'll need to install all your queries. This will take a little bit of time, about 1 to 2 minutes per query. So this is a good break point, kind of going through it to start installing your queries and then go back and sort of read through these queries and try to figure out what to do. So after that, that is really the majority of kind of the TigerGraph side stuff of where we're adding queries and things like that. So the rest of it will be building out the dashboard and then actually interfacing with the TigerGraph side to pull data out rather than creating queries on it. So very simple here is just setting up a lot of our styling. So these are just the main colors that we'll be using, as well as some images that we'll be including in the page as well. So that's just that basic styling setup that sets up our colors, sets up some of these images that we pull, and things like that. Next up, we're creating some of our genre list and our movie ratings. So this is getting all ratings for all movies as well as all genres. And what this is doing is this is running an installed query. So this is one of those queries that we created earlier. This one is general genre map, and this one is movie all ratings. So that's just kind of what these are doing and how you access those queries. You feed in, run installed query, the name of the query, and then we're actually taking the result of that and we're filtering it. So when you run one of these queries, you will get a JSON output, but that JSON output is contained in an array within an array. So all we're doing here is we're saying, I want array index 0, which is just our JSON without the array wrapper around it. And then histogram data is the name of the variable that we are returning. So if we were to look at our graph and this query, so that is general genre map, here we are, we can see that we are printing, which is more or less our return, histogram data as histogram data. So by accessing it through here, just saying histogram data, we are accessing the value of that variable. And we can see that this is a little bit of a messy printout of what it looks like, but here's our JSON structure with the categories. So each film has a set of categories within it: children, genre, thriller. And we can see how many movies correspond to that specific set of genres. So next, these ones are helper functions for creating some of our different Plotly layouts. So this is where we actually start getting into the Plotly Dash stuff. So here we're creating a figure. So this is go dot figure. Go is graph object. So this is a Plotly subclass. So this will create a Plotly plot, a Plotly figure rather, and that is an indicator type figure. And it has, we're displaying numbers and just some basic styling here. So this just describes sort of the styling of the font, the title of it and everything, and then some basic properties. So the main thing about Plotly Dash is not a new technology. It's a combination of existing technologies. So Plotly Dash is a combination of a Flask backend, a React.js front end, and Plotly components built in. So Plotly Dash is essentially a React app with a Flask backend and Plotly already integrated. So anytime you're creating a Dash app, it does all the heavy lifting to set all those up for you. And the only code that you need to write is in Python. That's all you'll ever need. You can write everything in Python. You can create HTML elements directly from Python. You can create your styling directly from Python. They have Python functions to do all of that. And I definitely recommend you check out the Dash documentation for a little bit more on exactly what is possible, but it is pretty cool that you can build a whole front end, back end website using just Python. So what this will do is this will create our gauge, and then we're going to return it as a dcc.graph. So DCC is, I'm blanking on what it is called right now, but that is one of our Dash core components. There it is. So we're pulling in that Dash core component, and because Dash has that Plotly integration, it has a bunch of these plots and charts already built into it. So we're essentially saying return this Plotly Go figure as a DCC graph. We're saying make the figure this figure, and then there's some basic styling which can be done here. And anyone who's done web dev before will just recognize this is kind of that same format that you would use to apply CSS through React. So this is the create the gauge. So let's just see. So that is this chart here. Oh, sorry, that's the pie chart is the genre stats one. The gauge is used within that. So let's take a look at actually that this pie chart right here, so we can walk through something. So we'll take our genres, we're going to break up them apart based on the pipe character. So if you'll remember, we had these pipes separating each specific genre. So we just break them apart. And then from there, from each one of those genres, we count them into a genre list. And then we display that on the plot. So you can see we are PX is Plotly Express. So you're not only limited to just regular Plotly charts, you can use Plotly Express charts, you can use D3 charts, anything that is a compatible React or Flask plugin, you can integrate with Dash. It's just as easy as doing it as if you were building it within React on itself. You just import it, and then you can call it from your dashboard. Everything included with Plotly Dash, like I said, is Python friendly. Any additional components that you may bring in may not have that same Python friendliness. So you may still need to write some CSS or some JavaScript in order to interface with those. But this will create a pie chart with our genre data. So we've just created a data frame of that genre list and the counts for each genre. And you can feed those data frames directly into Plotly Express, which is really nice because TigerGraph can also give you your query results as a pandas data frame. So it's relatively simple to go from executing a TigerGraph query, getting the results, and then taking those results and just loading them straight into a plot. So that way you can display that data. So most of these are just kind of those different charts on the different pages. This is our movies page where we're getting some of the quick movie info. One of the things I do want to talk about, we'll actually get to a little bit later on. And then this is just that person page, and these are all the relevant stats and functions for that. I can go through these, and I'll go through these in a little bit more detail if there's anything that stands out. But for most of these, it is just kind of that same pattern of running the installed query, retrieving the results of the query, parsing them into a format which the plot wants them in. So even though we do get data frames out of everything, you know, the plot may want them in one format and TigerGraph returns them in another format. So a lot of this here is just basic data manipulation just to get things into the right format for our plot. And then there, we just update the layout of our plot with our data. We add some labels to our axes. So this one has genre on the x-axis and count of number of movies of that genre on the y-axis. And then we can apply some styling as well, update layout and marker color. So all of those are just your basic visuals of what, sorry, that was the movie specific one. All of those are just the basic descriptors to describe the layout of this graph. And like I said, the documentation and Adbit's blog have go into a lot more depth here. I really just want to give you an idea of sort of the process and the flow that you go through to set this up. This section is for the radar chart. But now let's get into actually building out the dashboard pages. We built the charts, we built the functions to retrieve the data and generate those charts, but what does the actual site look like? What does that look like? So this is relatively similar to, like I said, React. If you've used React before, it's the same kind of idea for setup and the same way that it interfaces with components. So here we're creating some titles, and we're just doing that with html.center. So this is just creating an HTML element in the center of the page. Within that, we're creating essentially another div. So that's kind of what opening this up does. Is it says the content of this HTML will be a heading. And for that heading, we have the contents of our heading, as well as the styling that we will use. So our class name, any specific styling that we're adding onto there. And then color is just one of those HTML properties of our badge here. So this is a heading with a badge inside of it that says movie recommendation starter kit. So if we go back to our main page, we can see here that that is this. So here's our heading, movie recommendation starter kit. I don't know if you can see this too well over the video feed, but this is within a white box on a light gray border. So this, what was it called again? This badge is surrounding that. And then we just have that text within it. And additionally, if we look back at it, we can see we're setting the color to black. And then the rest of these just describe those other elements on the page. So there's similar setups where we're creating a badge that has a title and that has another badge within it with our numbers in it. So badge with the number of movies. And we can see that we're getting those number of movies. So this is one of the cool things. TigerGraph has built-in queries. So while we were creating queries before, there are a bunch of basic built-in queries to get stats about your graph. So for example, we're using the ones here, get vertex count, movie, person, rate. So if you look here, movies, person, and rate, we're using, we're using those built-in TigerGraph queries to actually extract that information. And these are super helpful for basic things like this, where you're just trying to get some of that basic information about what is loaded in your graph. You know, how many people, how many edges are there. You can even get more specific with this. And you could look into get edge count from a person. So we could say, starting from this person, how many movies have they rated by counting the number of edges. Those are all built-in functions to TigerGraph. And if you want to learn more about those, check out our PyTigerGraph video or some of our PyTigerGraph documentation, just to sort of learn what those included queries and functionality is. So that way there are things you just don't have to write your own queries for. Additionally, down here, we're following sort of that same trend that we had. We're creating a card. Within that card is our HTML content. So we have this card header, which has movies and our little projector emoji. And then from within there, we're then inserting these badges with our number of movies and number of views. So if we see movies H, we can see that this card here has this heading, movies, and then within it is that count of movies. So as we see here, movies, there's our little projector emoji, and then there's the badge with the count of movies. Let's see what else do we have here. So additionally, like I said, a lot of these HTML elements are sort of just declared as HTML dot, and then the name of the element you're creating. You want to create a div, HTML.div. You want to create a row, HTML.row, or this one's DBC, sorry. DBC is, again, one of our dash components. So much like you would use a library like Material or something with React, Dash has these components. So DBC is Dash Bootstrap component. So Bootstrap styling, if you're familiar with it, you can do it in Dash as well. So that's kind of the basics of how you set up that page structure with your different HTML elements, your different components that you would normally bring in through your other traditional front-end frameworks. This is how you do it through Plotly Dash. Let's see what other main things are there here. So a lot of the pages are just sort of laid out like this. You can obviously go through this and take a look at how things are going, but it is, like I said, that very basic format of including your HTML components and then populating the inside of them with the text or data that will go in, and then also the styling related to that text or data. So for example, here's an image tag, HTML.image source. Once again, if you've ever done web development before, you'll recognize these tags are just standard HTML tags for an image. So source is our Plotly logo, and styling, we just have some custom styling for it. You could also use CSS classes. So you could create basically these dictionaries within Python that just represent a different class, and you could just say, style equals Plotly image style, and I could have that as a variable, so I could reuse it across this page and have multiple things use that same styling. But where things really get fun, and I'll kind of scroll down to the end for this, is where we're actually setting up the app. So this will be similar if you've ever worked with Flask before. App equals Jupyter Dash. So here we have to specify we're using Jupyter Dash just because this is in a Jupyter notebook. If you were using Dash just within a regular Python environment, you would just do dash here. And then we're including in name is just the name of the app. And then external style sheets, this is where we can pull in some of those pre-built external file sheets. So we're using our Bootstrap one from Dash Bootstrap, and we're using Font Awesome for some of our fonts as well. And then this is where things get a little bit more, I'm not gonna say complex, but this is kind of where we're stepping into the backend side of things. So if you've done web development, we're stepping away sort of from React and kind of into the Flask side of things. So content, movie count, and person content, these are our 3 pages. So content is our main page, and then movie and person are obviously those pages as well. And we just specify which functions those point to. So if we recall from when we were looking at these, we can see that we were creating dash get persons page. So this block of code here contains all of the HTML elements of our persons page, and here dash get persons page, we're just setting that as our variable of person content. And then when we do go to render that page, so here we have a little if statement. So this is basically our which controls which page we're on based on our endpoints. So if our path name, if we just go to dash slash, that'll take us to our main page. And if we go to page 1 or page 2, this will bring us to our relevant either person or movie pages. So if we were to do that, this would just take us to our person specific pages. Obviously, we do this through the buttons, and those buttons just link you to those specific hyperlinks on the page. But one of the cool things, though, is these callbacks. So these callbacks are important to Plotly Dash if you have interfaces. So for example, if I had this search bar, or if I had a drop down or something where I wanted to change a setting, I need to have a way of acknowledging that the user has given an input, and then based on that input, I need a way of responding, so the page needs to do something in response to that input. So that's what these callbacks do. So this one here is for changing the page URL. So we have outputs and we have inputs. So our output is obviously what this callback is going to return, and our input is the change that it's looking for. So this one, for example, app callback, our input is our URL and the path name of it. So we're defining the URL as, I guess it knows the URL is our page. So it knows that that is what is up in this address bar. And if that changes, if the path name of that URL changes, then we're going to feed that into our callback function. With all callbacks, the callback function is just the function after it. So there's no explicitly stating this is the callback function for this callback. It's just because this is the function after this callback, this is the function that relates to that callback. So when this callback runs, so when we change our path name in the URL of our page, so by doing something like just page 1, when we change that, change to page 2, but you get the idea. When we change it, that callback will fire off this function. And what that function is going to do is feed in our input. So our input, as you'll recall, is watching our URL, and it's specifically watching the path name. So the path name is just that bit after the slash. And what it's going to do is feed that path name into our callback function. And our callback function is just going to do some logic to say, if it's just our slash, then we're going to return our general page. Page 1 will return our movie page, and page 2 will return our person content. And then what that does is that goes into the output side of our callback. And our callback will affect something on the page called page content. So in this case, page content is the content of the page. But if I wanted to affect something like one of our charts, then I would just give this, instead of saying page content, I would just give it the ID, the HTML ID of that chart. And that would specifically say, hey, target this chart with whatever we're about to do. And then the second thing, everything after the comma just defines what part of this we're going to affect. So page content is grabbing our entire web page, and children is the children HTML of that web page. So we're grabbing our entire web page and we're replacing its children with the return of this callback function. So in this case, that is the entirety of our movie content page, or that is the entirety of our general page. So these callbacks can be a little tricky just to wrap your head around at first, but basically your input is monitoring a certain part of the page. Here, I'll do this one. This one's a bit of a better example. So this one is monitoring the movie button. And it is specifically from that movie button, it is monitoring n__ clicks. So that is a value of the movie button. It's monitoring the number of times that that's clicked. And then once that is clicked, so once this fires off, that will fire off this callback function. We will take this n clicks as our input. And then we will output dash get movie page with a value in. So this will output then our dash get movie page to our page 2 content, and it will replace the children of that with this dash movie page. So basically this is the thing we're monitoring. This is the aspect of that thing that we're monitoring and also feeding into our callback function. And then the return of the callback function points to the thing that we want to change, and then the specific attribute of that thing we want to change. So it's a little tricky just to wrap your head around, but basically the HTML ID of what you're interacting with, your button or your dropdown or whatever, and then you would have something like this. You know, if this was a dropdown, the current state of a dropdown is stored as dropdown.value. So this would be value instead of n__ clicks. And that would just get fed in here, where it would take the actual value of the dropdown. So say I had a dropdown for some movies or something, and I selected, I don't know, Toy Story. This would take Toy Story and it would do logic on that. And then based on that, it would return something which would get fed into our output ID. Once again, this is an HTML object with that ID. And then we would see what we are actually affecting within that what attribute of that we are affecting. So those callbacks are kind of really the only tricky thing to sort of wrap your head around, of just how do we change what's on the page based on what we're doing on the page. But other than that, the rest of it is fairly similar to if you've ever used React before, if you've ever used Flask before. It's the same technologies, just with a little bit of a different layer on top of them to make them Python friendly. And then to actually just run, you just do app.run server mode external to allow it to access it. You'll need that here actually just because you're running this within the cloud. If you weren't running this within the cloud, say if you were running this all locally, you would not need this mode external because you would just be able to connect directly. And what this will do is just give you a link, which will bring us to our familiar looking dash page. So that was 1,000 miles an hour high level overview of kind of how to interface TigerGraph with Plotly Dash. So that way you can generate these dashboard pages, which are both interactive and also querying data from your graph in real time. So if I were to enter in a different movie here, I'll try some random numbers. Go ahead, that one doesn't exist. There we go. So this one will pull up a fresh movie, and we can see that as well. So that was just a live query to the graph, which ran some of those functions that we created in the past. So yeah, like I said, very fast overview, but kind of there's the basics of how you would build something like this out. Like I said, I highly recommend you check out Advit's full sort of walkthrough on all of this, both through the Medium blog post and through his YouTube video tutorial. And I will link both of these in as well, because they're very helpful. Here is this, if I have not included it already. And additionally, we are very happy here at TigerGraph to kind of hear what you think, listen to what you're doing, help you solve your problems. So if you do have any problems or questions, I highly recommend you come ask them at our community forum. So this is sort of where we go to answer and ask questions for the TigerGraph community. We also have a communities page on our dev site, which can point you to our Discord community, once again, where we're happy to help out and constantly answering questions there and sort of helping people show off their projects, work on their TigerGraph projects, things like that. And we have a link here to a view of our other community pages where you can take a look at some of our GitHub projects that you can integrate with your TigerGraph solution, or some of our YouTube learnings, our subreddit, things like that. So that's the majority of this. If there are any questions, I'd be happy to kind of take a shot at answering them now. I know this is kind of a lot of content for a short amount of time, but like I said, this is really just hoping to get everyone interested, and you can check out those fuller walkthroughs to get a better idea of how exactly to do all of this. Hopefully this just kind of painted the roadmap of sort of the steps you need to take in order to integrate TigerGraph with a Plotly Dash solution.
Yes, and thank you all so much for coming. So we have a special announcement. So one of the benefits of using TigerGraph and learning it, not only so then you can get a job with us, is that then when you see that we have customers, you can apply with them too. So next week and the following week, we're going to have 2 customers come and talk to you about what it's like implementing and using TigerGraph at their companies. One is like you guys, that's in a similar situation, that's relatively new. So he'll be able to navigate and tell you how he got his job, but also what types of things he's doing for a really big bank. And then we have an executive that's going to be talking to us the following Thursday at a huge company, and he'll tell you what he looks for in employees. So again, we're so excited that you're here. Thank you again. We'll be sending out all the videos and the quizzes. And again, we really appreciate it. Have a wonderful rest of your day, and we'll talk to you soon. Thanks again. Bye.
Thank you all.